I'm already recording. All right. The intervals we did before, p hat plus or minus, I am recording, p hat plus or minus z star, and then this was the standard deviation of possible sample proportions, okay? All right. So the only difference between what we did over the past 2 days and what we're doing today is this is really good at estimates. It estimates percents. Like what percent of something is, what is the percent that something's going to happen, okay? Or what percent of people believe in ghosts, or what, et cetera, okay? That's what, so its goal was estimating a percent. All right. If I want to, today what we're going to do is estimate means. And to estimate means, what that means we are going to use X bar. And our goal with using X bar is to estimate mu. Using the mean of our sample to estimate the mean of a population. All right, we can do this. It's going to be set up almost exactly the same way, where we're going to have our best estimate. Okay, when we were measuring our proportions, our best estimate was that p hat. It was the percent of our sample, right? So now our best estimate, or our point estimate, is going to be the mean of our sample. Everybody good? Okay, so we are going to, our point estimate is going to be X bar. Our previous margin of error was z star times the square root of the p hat 1 minus q hat over n. Okay? Here, our standard deviation is sigma over the square root of n, and that sigma is the standard deviation of the population. So, when we're using z star, do you guys remember how we calculated z star? We said, like for instance, if I want to be 90% confident, we use the normal distribution, and we said, well, this would be 0.9. And our tails then would each be 5%. And we would use inverse norm to find those cutoff values, okay? All right. Same thing. We're going to use the exact same thing. We're allowed to do that if one of two things is true. First of which is, if my sample size is big, like if my sample size is greater than or equal to 30, we can assume those means will be normal no matter what. Or if I know I'm sampling from a normal population. Okay? All right, so what that makes my interval estimate is X bar plus or minus Z star times sigma over the square root of n. All right, and then to interpret it, what you're going to do is say with %90 confidence, or whatever your confidence level is. You can say the population mean. Is between whatever your interval is, blank and blank. So again, the goal is we have our sample mean, which means the population mean, and then we get this interval that somewhere in that interval is the population mean. Okay? Let's do an example. let's say in this particular case, what we want to do is come up with an interval to estimate the average weight of 3-year-olds in Central Ohio. Everybody good? Now, is it reasonable to take every single 3-year-old in Central Ohio and measure their weight? No, that is in fact, very, very unreasonable. So we take our sample and use this sample to figure this out, okay? All right, so so we take a random sample of 5 3-year-olds, and what we do is we find that the mean of that sample, so the X bar, is 30 pounds. Does that mean the mean weight of all 3-year-olds is 30 pounds? No. Do you think the mean weight of all 3-year-olds is close to 30 pounds? Probably. Okay? All right. So we have that. It's probably worth noting that the sample size was 5. And let's see, what else do we need to know? Oh, we're told that the standard deviation of all 3-year-olds is 4.5 pounds. Lovely. So, my point estimate, my best guess at what the actual population mean is, my best guess is 30 pounds. My interval is going to be that 30 pounds plus or minus, let's see, 99% confident. I would like you guys to find the Z star for 99% confidence. Let's see if you know how to do it. This should be our 3rd day of finding Z stars, yes? What are you guys finding? You're finding the Z star? What are you guys getting? For 99%?
Wait.
That sounds great for a 90%.
Yeah, I think I actually.
You had to do 0.005, yeah?
I got 2.567576.
2.576, great. Okay, so we got 2.576 for our Z star times the sigma over the square root of our sample size. What was our sample size? We know this actually. 5. Great. Some of you do the minus, some of you do the plus. Tell me what you get.
35.184 for the plus.
30. 24.186. Perfect. All right. So what is that really telling us? Like when we do this, what we just said is, all right, this is our estimate for the mean weight of all 3-year-olds in Central Ohio. So the way we interpretate, I keep doing that. The way we interpret that is we would say with 99% confidence. We can say the population mean weight of 3-year-olds in Central Ohio. Is between 24.186 pounds and 35.184 pounds. That's our estimate. And guys, knowing that, what's my margin of error?
5.54.
You're going to take one end of your interval from the point estimate, right? So that, like, picture-wise, here's my 30, here's my margin of error, and at the end, I end up at 35.184, and over here I end up at 24.186. And the question is, what is each of these distances? When they should be the same because I added and subtracted them, okay? Inverse norm. Now, you guys, in grading your tests, which you will get back on Monday, we've got one person who's going to take it today. Okay, in grading your tests, okay, a lot of you put out answers showing me no work and got it wrong. And if that's the case, it's really hard for me to award partial credit if I don't know how you got your answer. Okay, so I really, really, really want you to make sure that you're showing work, because if you get the wrong answer and I don't know what you did, I can't give you credit for saying, yeah, you knew a little bit of what to do. Do you guys get what I'm saying? Otherwise, it looks like you could just put 0.5 for every single answer and I'm going to give you credit for it. That's not how that goes, right? Like, you have to show me some sort of thinking if you want me to give you credit. Everybody good? All right. There is, just like I showed you yesterday for the P hats and P, estimating P, there's a shortcut in that calculator. So if you hit stat and arrow over to tests, this is the one we did for proportions. This is the one that we're going to do for mean. So you're going to just choose Z interval, okay? And when you pick that Z interval, you have the choice to do this from raw data or from summary statistics. In this case, do we have the weights of each of these 3-year-olds? So I can't type those weights in a list. So what I'm going to do is highlight the stats, so that because then I can type in, all right, well, I knew the standard deviation was 4.5. I knew the mean was 30. Like, I fill in all that information. And it just happens to be filled in from my previous class, right? Okay, and I hit calc. And you guys see that we have the exact same interval. Okay, so I don't mind if you use this interval. You might want to tell me that you did a Z interval in the calculator if you want to make sure that you get full credit. Tell me what you typed in the calculator if you want to get full credit for stuff. Okay, or if you imagine you type one thing wrong, but you tell me you did all this, then I know that you just typed it in wrong. That instead of -4, you get -0.5. You guys get what I'm saying there? All right. Now, just like yesterday, we usually don't want to change our level of confidence. We want to stay confident that we have the right that the right answer shows up in our interval. So the way we ensure that we meet a certain margin of error is we get a sample size that's big enough to meet that margin of error. Okay? So because my margin of error has a different formula now, calculating sample size has a different formula. This formula is on your formula sheet. So what you will need to be able to do is, as you start to think things through, okay, you have to decide, am I going after a mean or am I going after a standard deviation or a proportion? right? So yesterday was all about proportions. Today's all about means. Monday will be about means, okay? And in order for us to do this, okay, we have to make sure we're picking the formula that goes with the thing we're trying to estimate in the first place. So did you guys catch what I'm saying here? Right? Like, if I'm trying to make sure my percentage is within 3%, this formula won't help me because this isn't the formula for percentages. This is the formula for means. So you got to make sure you're picking the right one. Okay? All right. So let's look at this one. Determine the sample size necessary to construct a 90% confidence interval for the mean age of all Columbus State students. We have the standard deviation of Columbus State students to be 17.4. And we want our margin of error to be within 2 years. Now, just because I want to make sure we understand, what does it really mean to say the standard deviation of ages for Columbus State students is 17.4? Start thinking that through. That means on average, students' ages from the mean age, the average distance is 17 years. So let's say that average age is 28. Did you guys catch my drift here? If my average age is 28, what's the center age? Not necessarily normal. What's 17 years older than 28? 45? My age? 17 years below. So the middle chunk is between 11 and 45. That makes sense at a community college way more than, say, at like a four-year university, right? And in fact, I even observed some of the coursework that I've taught you guys. Like, I went and watched them teach the course a couple times, and there was a woman my age in the class. In fact, there was a woman slightly older than me that was taking the course. And that's just how it works. It's kind of crazy. All right, so can you guys tell me what the sample size would be then? Do we have everything we need to fill into this formula? We need to find Z. So, what is the Z for 90%? 1.645, I agree. For now. Z star is a theoretical Z. It's like a boundary, and we call it a critical value. Like, it's where that middle chunk is. But like, there's all sorts of like, there is also each observation, in this case, each age of a Columbus State student, you would have your own Z. What are you guys getting?
Or like
204.8, right?
Yeah.
Okay. And then remember, we always round up. So in this case, because you can't, n is your sample size. If you give me a decimal for n, you will not get full credit because you cannot take a sample of 204.8 people. And then sample size always rounds up. There's one more example on the next page. I'm just going to let you guys do it on your own. Make sure we're all on the same page, and then we're good. Then I'm done. My advice to you would be start working through the Unit 7 homework, because the Unit 8 has a lot to it. Like, you're going to want more time for the Unit 8 homework by getting ahead on the Unit 7 homework now. I think I have it as March 10th. A week and a half. But then the Unit 8 homework's due really closely after that, and it's longer. So you should, if I were you guys, I would think of it as the Unit 7 homework is due by like this time next week. Wednesday or Thursday. You'll be in a good place to have it done by the end of that block day next week. I would think. The Unit 7 lab was quick. I started it, and it was a pretty quick lab to do.
Yeah, I rounded up, so. I feel like this is
Should we round up the price?
You always round up sample size. Because remember, you didn't find the price. You found the sample size.
Oh, so it's 30. You said the lab was quick.
Yeah, I'm going to go back and double check, but I think the lab was pretty quick.
If the lab was quick, then it's gonna be, everyone was longer.
I mean, the lab is not quick enough that you can get it done.
No, but like start on it, like.
I think I would choose to do the homework for 2 reasons. Number 1, your progress automatically saves. And 2,
Populations, yes. So anytime it says determine the sample size, you always run out. No matter what.
yeah, you guys, this would be an example. Your sample size needs to be 39 people, not 38.
If we could get like a exact, like let's say it was exact.
I'd put it up one.